And you're on.
Hey guys, here I'm Nick Johnson, Paladin Consulting. This is James Hess,
Hey,
my new friend, Joe McMasters. So, we thank you guys for coming out, for being with us, for watching the broadcast and checking it out at home. I'm sure that we will all have some very wonderful things to say about this conference, and those of us that were not able to attend will feel like they've sorely missed out. I know I certainly do. So, appreciate you guys coming out as always. If there's anything that we can help out with, please let us know. If there's any career counseling or advising or resume writing, anything to help you guys get a new job or get the job that you want, certainly feel free to reach out to Paladin Consulting.
Great.
Thanks
so
so
much.
All right, guys. Enjoy.
Sure. Hey, guys. So, and hello, everyone online as well. So tonight it's a little bit of a different format. We're going to be a little bit more informal. We just got back from the DevOps Days conference at the beginning of this month, and so that was a lot of fun. So we wanted to talk about that, some of the things that we learned or experienced, and then after that, I wanted to do a little bit of show and tell with a Vagrant and Docker example or setup to give you some exposure to both of those tools, bringing them together, and how to debug them live, and so we'll do that, and then if we have more time after that, we just want to get a little bit of feedback because we're almost about halfway through the year. We want to get an idea from you how you're growing in your DevOps journey, what you're understanding about the tools, what you're having hang-ups with. And also we'll be preparing for our annual conference. We'll be starting that process pretty soon as well, and want to get some feedback from you and also the companies that you work for. What kind of things that they would find beneficial, what things that they want to hear at the conference. So let's go ahead and start by talking about DevOps Days. So the DevOps Days conference was a 2-day conference, and let me see if I can pull up the website as well. It's devopsdays.org. I'll bring it right here. Cool. And then so we were the Austin one. It was at the Marchesa, which is little civic center type thing they had going on, and they had 2 days full of a technical track and also a more business track, and so it was pretty cool. The keynote speaker, he did a pretty good job at setting the tone. One thing that made this conference different from the one last year is that they focused less on the culture part of DevOps, which, are you familiar with the CAM cycle? You've heard of that? So in DevOps, there's this acronym called the CAM cycle, which stands for culture, automation, measurement, and sharing. And so they say that any organization that embraces DevOps, you'll see this cycle happen within it, where the culture influences their automation practices, their pursuit in gathering measurement and making decisions on that, and then being able to share that data, which then again influences the culture more. And so at the 2013 DevOps Days conference, they really focused on culture a lot. They said, that it is really pivotal to be sure that you're in a culture where this stuff can be, this stuff can foster. And so what the response to that from a lot of, what they said is that, if you're not at an organization where this can foster, then you should quit your job. And so, that wasn't necessarily, very heartwarming for the people that represented enterprises or large corporations, because they've got a lot of legacy systems. And so conversely, this year, they didn't talk so much about culture. Their theme was practical DevOps. That's right. So, that was, what everyone wants to hear, I guess. and so what the keynote speaker what he said is that DevOps doesn't necessarily come natural. You're not born a developer. You're not born a systems administrator, um, and so these are skills that have to be acquired and nurtured and grown and practiced. And similarly, being able to apply DevOps principles, it's not going to come naturally. So, and plus, a lot of organizations, they're still very hostile in their collaboration efforts or their ability to communicate between departments. And so that causes a lot of problems. And so he said, but just because it's hard, you have to do it anyway. You have to move forward. And so it's language that defines us. We have to have common verbiage across the entire business if we're going to be able to bridge some of these gaps. I mean, you can look at different aspects of departments and organizations, and you might see different acronyms being used or different jargon. So, if you're sysadmin, you might be familiar with like SSH or LAN or Bash or TCP/IP or HTTP or SAN. Those kind of jargon terms. But if you're like if you're a product owner on an agile team, you might be more familiar with like TDD or CD for continuous delivery, or CI, velocity, sprint, and stories. And if you're there to represent the business, then you're probably more familiar with terms like IRR or NPV or P&L, ROI, and margin or M&A, IPO, those kind of things. And so in that regard, I mean, it's important in order to foster a DevOps environment. You have to have this convergence on these terms, these jargons. Like, more people need to have cross training and understanding of these things, because it's really easy for someone on an IT or a dev team to kind of get lost among the trees and not see the forest for what it is. They need to get a higher level view to see what value from a business perspective that they're really providing. So they really talked about that, and so they said that there's a way to do this, and that way is in training. And it's becoming acquainted with every art, knowing the ways of professions, distinguishing between gain and loss and worldly matters, develop intuitive judgment and understanding for everything, perceive those things which cannot be seen. That's kind of a weird one. Pay attention even to trifles, and do nothing which is of no use. And so that may seem kind of vague out there. He pulled a lot of this content from a book that was actually about samurais. So he was heavily influenced by that. But the idea is that there's a concept called unicorns, and unicorns are referring to companies like GitHub and Etsy and Netflix. These guys that seem to be doing really big things, but the things that they're doing, like, we can adopt as horses. In our organizations, we can put on a little spiky hat and pretend to be unicorns too, if we begin to follow some of these practices. So it was a really good event. They had lots of really good talks from a technical perspective on how to use Docker or Vagrant. They had some talks on different metrics gathering tools, some StatsD or Graphite. They had some hands-on workshops on spinning up your own. I guess you could look at some of these. One of the cool things also is they have these things called open spaces. Are you guys familiar with open spaces? You've heard of it? Yeah? No? No? Okay. So an open space is where people that attend the conference, if they are not hearing the kind of things that they would expect to hear at the conference, they go up and they pitch an idea that they want to talk about with the fellow peers or conference attendees, and then they ask the audience, all right, well, are you interested, or who's all interested in joining me? And they do a raise of hands, get an idea of how much participation that they would get, and then they split out into large and small and medium-sized groups to then talk about those things. So they had a lot of open spaces sessions as well. And so what that does is it gives a lot of customization to the experience for the individual who's going to the conference. Make sure that that they're able to get the kind of business value out of going to a conference like that, and bring the information back. One
of the interesting things, I was talking to some of the guys from a large financial firm, and one of the things they were talking about in terms of business costs versus technical costs was, for them, I mean, they were aware that sure, DevOps is the right way to go, and there were different degrees of being close or far away from that, but they had to make decisions that were like, how many people do we have who know various toolkits in this super large organization, and how much legacy stuff do we have, and how much does it cost per month to bring this legacy stuff one line of code at a time over to the modern world? What if we just leave it the way it is? One of the interesting things that they were talking about is, hey, this legacy stuff, yeah, maybe we can get away with leaving it the way it is for a while because it makes sense financially, but eventually we won't be able to find somebody who knows how to maintain it, because they don't teach that stuff in school anymore. I mean, things that were in the 70s or the 80s or whatever. So that was pretty interesting. So some of them, I think sooner or later, a lot of these will move to DevOps because they have no other choice.
Right.
They have to move because there's nobody to support old legacy stuff. They have to have a new way of putting software together, developing it, pushing it, testing it, automating everything. So that's going to be pretty interesting.
Yeah. Yeah, I mean, at the end of the day, for a lot of organizations, the reason that they pick up on DevOps is because they believe the philosophy that in order to innovate, you must be able to iterate quickly. And in order to iterate quickly, that means you've got to push things out the door. And so that way it gets into the hands of your customers, and that way you can get feedback quickly. And so the company who's able to do that is able to out-innovate the company who is on these 6-month or multiple-month or even multiple-year deployment cycles. So, I mean, yeah, it really comes down to providing business value by iterating and innovating quickly. So, did you catch any other cool tidbits while you're at the conference?
I mean, there was a guy who did a talk. I guess it was a video of his talk from the previous year.
Mm-hmm.
It's pretty interesting, but I don't know if actually I think he didn't show it for a purpose. I don't really want to bring it up, but
okay.
Yeah. No, I mean, overall it was okay. I mean, I spent a lot of time in the car sleeping, so that.
That's right. Yeah. Alex was really tired because he had his own deployment to do during the conference. So. Yeah, so it was a little challenging for him.
One of our clients decided that they wanted something yesterday.
Yeah.
So it's like, okay.
Yeah.
No sleep for me.
Right. Yeah. Yeah. So that's it for the conference. Let's jump into some show and tell. I'm gonna talk about Docker for a little bit. So let me go back to sharing my screen. Again, there we go. Okay, so first, who knows about Docker? Who's familiar with Docker? Have you ever heard of it? All right.
I've heard of it, and I tried to play with it.
Yeah.
I got the SSH port forwarding working, but
yeah.
I didn't go much further than that.
Okay. All right. Got it.
So
yeah.
I've also worked with VirtualBox. Yeah, that.
Okay. Right. Okay. Anyone else? No. Okay.
Not usually.
Okay, got it. So, so Docker is a lightweight kind of like pseudo virtualization mechanism. It's not true virtualization in that you are not provisioning virtual machines. What you are doing is you are isolating a portion of your Linux kernel and creating a sandboxed environment that is reusing the hardware of your host machine. So you're not dedicating CPU or memory amounts to isolated virtual machines. What you're doing is you're letting these sandboxed instances share the hardware with the host. One thing that is unique to Docker is that it is built for the Linux kernel. I mean, it's using LXC containers, which are Linux containers, which means that it is not compatible with Mac OS or Windows. You probably won't see native Docker or native LXC containers on those platforms. However, the community has done some interesting things where with the help of VirtualBox, you can spin up a lightweight, flat, like real base image of an Ubuntu VM with Docker installed on it, and then you can port forward the connection to your host machine. So what that means is that from your Windows or your Mac machine, you can interact with Docker as if it were running there. And so what this means is that you can do development on Windows, you can do development on Mac, and then you can deploy it in the cloud in Linux, and so you should be able to get an exact replica environment, an exact duplicate environment in your dev environment, as well as what you end up shipping to production. So the idea behind Docker is that you can containerize all of the portions of your application, and so the idea is that if you say had a chat room app that had a database component to it, that what you might do is create a container that includes both the application and the database, or you might create a collection of containers. Like one is a database container and one is the application, and you can link them together. And so what ends up happening is that the network interfaces and the gateways get set up and are isolated to be talking between these containers, and they don't actually need to be exposed out to the public or up to your host machine. And so I mean, the real benefit is that what I can do is I can provide you a Docker file, and you can spin up the exact same environment that I have just by provisioning that Docker file. And then another cool component is they have what's called the Docker index. And so what you can do is you can pull down containers from the Docker index and then spin up environments just based on what you downloaded. So if you're familiar with things like apt-get, if you're using Ubuntu or other package managers, maybe like npm or Gem if you're using like Ruby, this is really an easy way to spin up environments or dependencies that are full running applications just very, very quickly. And so yeah.
But are those kind of like what we were discussing, like Omnibus, like basically say whatever app you have, like it comes with its own Ruby bundle, so you don't spend time the dependencies.
That's right.
Okay, so it comes like fully.
Yeah.
Basically, very functional.
Yeah.
Okay. Even though it's possibly wasteful, supposedly, but resources are cheap now. So.
But the Dockers stay within their own container.
Right.
That's right. Yeah.
Well, that was the other thing.
Yeah.
How do they, like you mentioned, they can talk to each other? Is that like some kind of IPC, which kind of bypasses? Like, do they have to go out to talk to each other, or can they? Because that would be violating the partitions, I would think. So how do they?
Yeah.
What are the recommended ways?
Yeah. So with a Docker container, what you can do is you can pick the ports that your application is sending data out out from, or like need to be exposed, so that way you can connect to it. And so, for example, if I have a database that is that you can connect to it over port 5843, then what I will do is, if I have my app in a different container, I may link to the database one, and that'll open up port 5843 as a direct connection between this container and the database container, the app container and the database container.
Okay.
Yeah. And so another interesting thing about Docker, though, is that you can commit, just like if you were using version control for Git, if you're familiar with that, you can commit the state of your container. So instead of using Docker files to provision them, at any point in time, you have the ability to attach to the running process or log into that entire environment, because it's an isolated environment. And if you need to make some changes, you can on the file system or whatever you need to, and then you can jump out of the container, and then from your host machine you can hit Docker commit your container name, and it'll save the entire file system as it is at that point in time. And then what you could do is you could create new containers in the future that are instantly at that state where you did your last commit.
So by file, you mean like a file system file?
Yes.
Okay.
Yeah.
Or do they correspond to some like image format? I mean, like what is it? There's the .box format, which is
right. For probably like for VirtualBox or something.
Right.
Yeah.
Well, more so for something else which flash past. But I mean, so are these like binary files or just blobs?
So they're just blobs.
Okay.
Yeah. Yeah. So so let's jump into a demo. You can maybe see some of this stuff. So I'm in Mac. I'm in Mac OS X here. I'm in Mavericks. You can see that I'm in a project directory, and I'm going to be spinning up an app called Kundan, and it's a little chat application. It does persistent chat, kind of like HipChat, if you're familiar with HipChat, or Campfire, if you know Campfire. And so I am first going to open up Emacs. We can take a look at some of this stuff. Okay. You're chuckling. Is that because I'm using Emacs? Yeah. Yes, it's good stuff. So here I have my Docker file, and so can you see that? Yeah. So this is all that it is pretty much, and so I'll explain some of this. So this is our dependent container. So in this case, in the Docker index, I can search for Fusion. It's passenger. Yeah, it's this one. This one here. And so so this here represents a container that has Ruby installed on it. It's version 1.9. It has all the dependencies installed as well. It's got native binary support as well. And so what this means is that if I spun up a container that was this passenger Ruby container, I could instantly start doing Ruby development. I didn't need to install Ruby on my local machine. I could jump into that environment, start doing development immediately. So that's really powerful, because that's an easy way for me to transport that stuff. So in my Docker file, what I'm saying here is that so I'm using that as a base image, and then I'm going to be applying my stuff on top of that. And each one of these lines here represents a commit to the new container that I'm creating. So it's saving the state of my image with each of these commands. Cool. All right. So if we take a look at this, the first thing that it does is it's going to run apt-get update, and then it's going to install some dependencies that I need to run the Kundun app. Then it's going to go out to GitHub, and it's going to clone the repository of the app. This here says that it's going to make all future commands happen in this directory. So this is my working directory. Next, it's going to run this command here, let's see, and so this is going to do a bundle install. So this is going to install the Ruby gems and dependencies to run the application. This this here. This says run the database provisioning scripts and anything that it needs to get the application ready. And then here, this is the command that will actually start the application. So this is the command that will run. The Docker container then says, expose port 3000, which is where you can access the application. So if this was currently running, I could hit it at port 3000, or this would port forward to my host machine from the container's port 3000. And then after here, it's just some stuff, delete temp files, delete, clean up some stuff. So I've got Docker running here, but I also have a Vagrant file, and so this is cool because Vagrant 1.6 just launched, and it has Docker support in it. And so what I'm doing here is I'm taking that port 3000 for my Docker container, and I'm gonna send it out of my Vagrant VM. And then down here, I have some provider information here that says it says turn SSH on, so I can do Vagrant SSH, and that'll jump me into my Docker container. This says what username and what SSH key to use. This says build the Docker file. This here is interesting. This is actually a Docker proxy. So because I am on Mac, there has to be a Docker proxy VM, and so that's what I was talking about before. It's a small VM that's going to spin up in VirtualBox, and Docker will be installed there. But then my Mac can connect to that. If Vagrant detects that I'm on Linux, it knows that it doesn't have to spin up VirtualBox, and so it'll just hit Docker directly. So this is just a proxy VM that gets me to Docker. And then that's really it. I'm not doing anything else. After that, it'll run my Docker file, and that's it. And then if I look at the Vagrant file of the Docker proxy, I'm setting memory allocations, some CPU allocations. I'm doing some port forwarding stuff here as well. So I mean, that's all there is in terms of this. Let's see if we can get this running. As we saw earlier, we were having a little bit of problems. So I'm gonna export a TCP port and see if it's currently running. So it thinks Docker is currently running. I'm gonna open up VirtualBox, and we're gonna see what it thinks is running. So it does not think any of my Docker VMs are running. So this is interesting.
So is anything listening 142, whatever that?
That's what this would be indicating. Yes, that something is currently listening to it. Let's see if we can find out. So we got Chrome, a bunch of places. Here, let's do some net stats.
TLP invite.
Oops.
T would be TCP.
Yeah.
Dash
TCP dash P. TCP after.
Oh, cool. So I don't see anything on that port. So let's keep looking.
So that's
Yeah. It doesn't have any images in it. That's interesting too. Let's do Vagrant. Okay.
Why don't you just choose a port?
Um,
I mean, or
so it's built into Vagrant to listen on that port. So, but we could do like you're saying.
So instead of trying to find what's going on.
Yeah. So let's try that. Let's add this guy here. Oops. Yeah, we'll give that a shot. And then
so while that's going on, like if anybody is saying, you can bring up basically Vagrant on a virtual box and just bring up a Docker instance that will kind of behave like what used to be the virtual box VM, Ubuntu, whatever it was in the past.
Well, the only reason you use VirtualBox on a Mac is because Linux contains a container and use it on the native local.
Proxy, which is a full-fledged VM.
You've got a bootable Linux box on your Mac.
Right.
Install it.
Okay.
so when you are in a container, it defaults to running all commands as root. And so for this particular application, I wanted to run it as a user named app. Let me. When is the app user created?
Right.
So the app user actually comes container. So this container, it created the Ruby, dependency. It also created the app user.
Okay.
Yeah. So I'm running it as that user in this case.
So the only reason you have to use sudo.
That user. That's right.
But when you do something as root, like defaults to within, it remains within, like it remains. Like, I mean,
that's right.
Okay.
Yeah.
Conceptually.
Yep. All right. AB302. Okay.
Yeah, that's what I'm trying to figure out. Why do we go? But okay, so that is okay.
All right. What else? Here, I'm going to.
Want a colon before the forward port?
Where?
Yeah, it's a symbol.
Quotes. I was just curious.
Yeah. In all my tests before, it was working with the quote. So I don't think that's it.
So who's listening on that?
Do what?
Who's listening on that port?
Yeah, right. Let me. I am going to kill my Docker proxies manually, and then we'll see if that changes things. Then try this. Nope. I guess I should reboot. Yeah. Unless anyone else has some ideas.
No.
Okay. Yeah. Let's reboot this.
Well, the only thing is, unless whatever was listening on that port is.
What's going to happen to the Right.
Yeah. So while I reboot this, we'll keep.
I've run into that before.
Yeah.
Where it still thinks there's a port open somewhere from Vagrant.
Well, it takes a little while for it to die.
It's a vagrant
Yeah,
issue.
it's a big.
Yeah, it is. It is a vagrant issue, right? In this case.
Because I've tried bringing VMs before and couldn't log in the SSH forward. So it's like,
Yeah.
Reboot.
Yeah. Okay. So I'm back up now. So just a moment, I will rejoin. Let's try it real quick though. I'm gonna just destroy some vagrant stuff. Okay, destroyed.
So was there any, what is it?
Yeah.
Any so-called, consensus or cool new thing that comes in the future?
Right.
Like, was there any? That kids are doing now. We need to be doing this.
Right. All right. I'm gonna rejoin the Hangout.
Yeah, I don't know about I didn't hear anything particular that session, but I would say Docker is probably a good example of that.
Yeah, that's what I keep hearing too.
So I mean, their philosophy is, as I read it anywhere on the site, is that they, like the shipping containers are all uniform, and they're all, when you ship them here to China or wherever, it's the same shipping container, right? Because the barges have to be built a certain way, and the crates have to be built a certain way. So unifying that, you don't care what's inside the containers. That's their philosophy.
People don't realize how much that's revolutionized the world over the last 30, 40 years.
I mean, that's exactly what all the package managers have done too, right? They're saying, hey, look, read your thing, but have a sensible interface to installing and configuring them, whatever. Have a config file at the top or
And
certain directory structure or something. Otherwise, every time you have to incur the cost of, let's make our two things talk together, or with the environment that it's running in, or whatever.
Exactly.
Or you're back in.
Yeah, back in. All right. Yeah. So all we ran is vagrant up -- provider equals Docker. I think perhaps the problem before is that I manually exported the TCP port forward, and perhaps it does it automatically here. So I'll put a issue on the GitHub for that one. And so it is building the container from Docker now. And so if I open up another tab here, I can do Docker PS. Oh, here's the, yeah. All right, this is what I think broke it last time, because I did this. But I'll do it now so we can see what's going on here. So, so we can see that it pulled down the passenger Ruby container here. And now it's building my container, the one that I had the Docker file for. And then we can see kind of the status of it over here. I'm going to let this go down here, and you can see a little bit better. So I'll run Docker PS again, and you can see, 30 seconds ago it started this command here. If I do Docker PS, the full details, so it's at the part now where it's doing the apt-get update, and then grabbing these dependencies here. So it's in the process of installing that. If I go back here, yeah, it's building the container. So we'll just let that go for a little bit.
And you're building the container, you're not deploying the container.
No. Yeah, I'm building it. Yeah, so a deployment would be, running the, you could pull the Docker container from the repository on your actual machine.
Right, I was just looking at it saying the first step was, what, inside of 5 seconds, done.
Yeah.
And 600 megabytes or whatever it showed.
Yeah.
And then this last part is taking a sweet time, but it's because it's actually doing downloads and installs and changes.
Yeah, like this one here represents 600 megabytes for the Fusion Passenger stuff. And now it's running individual commands, and that's continuing to grow. Yeah.
The nice thing about this is once you do this once, like you said before, each individual line in that Docker file is a commit.
Mm-hmm.
So if you redo something, it knows that commit is kind of already committed to disk.
Yeah.
So it blasts through until it finds something that's changed.
It doesn't have to rerun that step.
It starts from there again.
And does that rely on, like, say, for example, apt-get commands, like, they have their own database, or is it, like, idempotent, like, just
I think
based
it's more
on
of a Git type of thing. It gets to a certain point, and then it snapshots.
Okay.
It gets to a certain point, and it snapshots.
Yeah.
So every time you run a different line in that Docker file,
Right,
you're getting
right.
a different commit into the Docker history.
Interesting.
And you can flush that cache, but it's really meant for speeding things up when you've got all of these commands, and the last one you have to tweak a little bit.
Right.
8,000 times faster.
Yeah.
I think they have kind of like a file system that supports diffs. So it's basically each thing is another increment. That's why you can kind of save a snapshot and revert and do all sorts of stuff, much like a virtual system.
Yeah. So let's take a look where it is now.
Is there anything which doesn't support that? Or?
It's doing the bundle install right now.
Everything's a file.
Yeah, I mean at the file system level, I think it's a generic thing.
Okay.
Yeah.
They just save the diff.
They're not running they used to require UFS, but now
No, it's not required anymore. Right. Yeah. I don't even think that's the first choice now. Yeah.
I don't think it was ever a happy choice. It was one of those things that did.
Right. Yeah. In fact, it's not even using LXC containers as a default implementation now. You can fall back on LXC containers. So that means that there's different ways to jump into your Docker instance now. They've created some Go apps that let you jump into it and take a look around. So yeah, it's still doing the bundle. When I did this in the past, it normally took 7 minutes for the bundle to complete. One interesting thing is that you can do Docker logs on so it gives an alias automatically if I don't specify one. So I can do Docker logs and put this in, and it'll tell me what some of the output is. I do notice that when I'm on Mac, it truncates a lot of it randomly. So if I do this enough time, we should eventually see some gems, showing up.
Is there a follow the logs command?
A what?
Like follow on logs command, like on -f.
I don't think so. Oh, look at that!
Wild code.
Look at that! Look at that! No, see if it's not working.
It's something that's written in the log file.
Or you can pipe it to less and then you
Right.
get that.
Let's see. Follow. See, but it's a
Well,
liar.
this is the current end. Shift F.
It's a liar, though. I'll show you. We'll do this enough times.
Right.
Here, go back here. I want to check the progress. So we're still there. A couple more minutes. Wait. See? I'm not a liar. See?
Yeah, now it's actually doing a bunch of gems.
Well, see, but it was before. Yeah, see, but now I do logs again. That's what I'm saying.
Okay, I get you.
Yeah. So it's a liar.
A little bit buggy.
Yeah, but I think it's because it's piping that through VirtualBox, So because I'm on a Mac. So, yeah. Okay. And it is at the part where it's executing stuff.
Yeah, that looks like this. So you're running.
Yeah. Oh yeah. That's right. I am running. You are correct. It is currently running right now. This is the name of the app. It is port forwarding 3000 to my host machine 3000 and also port 22 to port 2222 on my host machine. What this means is that, yeah, and Vagrant told me it's now booted and ready to go too, so that's fine. What this means is that I can do Vagrant SSH, and it's going to SSH into the Docker container. I can, poke around as root, so this was installed to home app pendon, and then there's the files installed there. It already did its bundle, so that's fine. And so let's see if we get any new logs, Docker logs, or let's get the. All right, this is the name of the container. So Docker logs. Sorry. Well, that doesn't tell me very much. Okay, so let's see what happened. It's currently port forwarding port 3000 on my machine. So let's take a look at what we get. Whoop. So localhost 3000. And I know that on the first run, this app, it begins to bundle things and do some compiling of assets and whatnot.
Wake up.
Yeah, it does some waking up to do. And then there we go. There's the app. So the app is now running. I'll sign up. Or actually, I know the admin credentials. Admin. And there we go. So this is my little chat. Can we make this? Let's see. Yeah. There we go. Yeah. So this is my little chat app. You can watch a little YouTube video here. You can talk with your friends. And it's a persistent, chat room. So this is really great for people that that are in organizations that have long email chains and want to stop that from continuing. They can just have persistent chat here, and you can search it. So type in YouTube, and and there, you get some of the history in the chat and a little bit of context. So you share images and all that stuff. So so yeah, that's pretty much it. So any questions? High level.
One thing which I looked at in the past for, like I said, I've never actually used containers, was C groups, like basically, keeping performance within, bounds for things. So, how do you do, like metrics collection on, Docker instance, one versus the other, or are there things which, basically can be what is called noisy neighbor effect?
Right.
That one instance is, somehow trampling over the others. How do you basically keep those things? Do you just rely on C groups, or?
Well, so so if you build into your container a way to send information out, then then you can listen on that information because it's forwarding that port.
Right.
It's exposing that. If you have like an agent installed inside of the container, then you want to also expose that port so that way your systems can listen on that. That makes sense.
What type of agent would that be? Just any metrics, like on
Yeah.
Unix, like the Linux level, like it doesn't know it's living in a container, but it's just a
right. Yeah. Yeah. Yeah, but unless you're exposing it through a port, then the data is not accessible unless you mount a volume. So when you create a container, you can mount a volume on your host machine, and it shares that. And so, for example, if you had Nginx running and you wanted to have it write the error logs and the access logs to your host machine for you to aggregate and push to whatever, you could mount the directory of your Nginx volume there. And so when it writes to it in the container, that is exposed on the host machine. You can do things with that.
Also, outbound ports don't have to be mapped, so if you had an agent like
right.
Yeah.
like New Relic or Scout or something like that, they could be reporting those metrics out to a third party.
That's right.
Hosting provider. So you can do it that way.
That's probably if you control it. Because if,
That's
you
right.
know, if this were like a past thing or whatever, you wouldn't want your
You're
clients
talking about
reporting their own
something,
usage. So you'd need some sort of external thing to, you know, if you give me space on your app, I mean on your box in my little container, you shouldn't ask me to report my usage to you because obviously I can report my usage to 0 and use forever. So probably there needs to be some external monitoring.
Right.
Interesting.
Yeah.
So what does the container look like to the host Linux system? Is it just a single executable running? Or?
So
In this case, it would be VirtualBox.
What's the container? Because could you take your from the host Linux?
That's what I'm saying. That's how I would see it working. Yeah.
Because if it's chained and it's jailed.
yeah. Well, so this is forwarding, you know, all of the Docker commands. So Docker, it has all of its blob storage and all that stuff stored on the file system in its, you know, own, root accessible only location. I can't access it through this proxy right here. But if I'm on the actual, Linux machine, then I could get there and then, you know, check out whatever I needed to. But in most cases, I can extract a lot of the things that I care about just from the tools. So options. You know, you can attach to a running container. You can build from a Docker file. You know,
Can
all
you
of
do
these things.
like can you show like RF star and then like recover from it?
Yeah.
Do that.
Sure. Yeah. So like within the container, or like do you want to like delete the container and
Well, in the container,
re-provision
yeah,
it?
don't do RM outside.
Okay. All right. So let me do Vagrant. And
So, sorry to interrupt, but like, what does it mean attached to Docker? Like, you know, I mean, like, attach some new command or
No,
what would it
attach
be?
a console to it.
yeah, attach consoles.
So that you can talk to.
Kind of like I'm doing with Vagrant SSH.
Right.
Yeah.
Okay.
So
Nothing to do most of them are exotic.
CD Canada.
Attaching
All right.
like GDB or
So in this case, let's kill some stuff. We'll do RMF dot, right? In your scenario, that sounds good.
RM-RF/.
All right.
That's the best one.
Right.
Good.
That's
That's
one-
fine. That's
the one
fine.
command that rules
Yeah,
them all.
that's fine. We'll do that.
Ruins
We'll
them all.
we'll see what happens. All right. No preserve.
Wow, they have added something.
Yeah, there you go.
Oh, there you go.
Cannot remove a bunch of stuff. Permission denied. Let's see. No such directory. LS is gone.
Right.
See, yeah.
You can do
Okay.
CD into nothing.
Yeah. Let me do Vagrant SSH again. You know, we'll see what happens. SSH is closed. Yeah. So the Docker container is pretty much hosed at this point.
I thought you were saying that you can do it and recover.
Yeah, we're gonna recover.
Oh,
Yeah.
okay.
Yeah.
The recover part.
That's right. Yeah. Yeah. We have not recovered yet.
No, well, I mean, even if you destroy something like this, so we do, but
Yeah.
Yeah.
So what I'm gonna do is I'm going to do okay, I'm going to do vagrant F and a vagrant provider equals F. And then I guess I should have done the thorough test of like going back here and seeing this fail, but you know, the Docker container's off now. Yeah. Yeah. So anyway, it says it's back up now. So let's check it out. It might be lying. No, maybe it is lying. Docker PS. Okay. That says a new one. Yeah, that says a new one. So let's check it out. Oh, it was just we're doing the pre-rendering stuff. Yeah.
The container's got to come up.
That's right.
Ruby's got to come up faster.
Bingo. Smart thinking. And bam, we're back. So yeah.
No, that's because the container was a copy of it, if you will.
That's right.
Was still present on the host machine.
That's right. Well, it was in the Docker. So if I do Docker images,
it was in a different silo.
Yeah, it was right here. It's this guy that's unnamed right here. When we ran the Docker file, it created this image here. It's using this image to reprovision. Yeah.
So this guy has all those apt-get commands and everything that can do.
Yeah. Right, because of the Docker file. Each run was a commit. So this image hash right here represents the latest commit hash where it was.
So every time it's run, it creates a copy of it, which is the kind of, as it were, the read-write version of this guy.
Yep. Yep.
Okay, so silly question.
Yeah.
You got a gig and a half gig over there.
Yep. Yeah, we're in 2014 where space is plentiful.
Right. So I was just looking at it saying, okay, if you're going to have 10 servers with 10 containers on each one, all serving the same app, right?
Mm.
The gain here is that you drop one image on there.
Yeah.
It spools up, takes, what did we take, 15 minutes the first one?
Yeah.
And then the other 9 are instant.
That's right.
Right?
Yeah.
So if we make a version change, it'll move up another image, another gig, right? Which is fine.
No, because
it takes a binary diff between the two versions.
Bingo.
Okay.
So if you only change 20 megs worth of file, you're going to get a 20 meg diff.
Yeah.
Okay.
So, yes. Let's see.
And unlike VMs, you're not installing an operating system and an app into 10 different containers.
Sure.
Right. Yeah. In fact, let's spin up some more instances,
So
shall we?
one of the things which you kind of mentioned was basically say if you're running 10 instances or say 15 instances and you have a 16 gig RAM machine.
Mm-hmm.
So basically, is there any kind of some sort of optimization of memory usage between containers, or are they all consuming their own gig each?
No. Well, so the host machine manages the memory allocation.
True.
Whatnot. So.
Okay.
So it kind of knows how much to do that. But
Yeah.
you can get into advanced features where you are setting quotas,
Yeah.
for these containers.
Okay, so basically that's usually not the bottom.
Yeah.
Okay.
So if I can create some more, jump out of Vagrant at this point and kind of go off the training wheels and kind of see what happens.
Mm-hmm.
So, there be dragons ahead. So let's do Docker run -d. Let's see what I have. Port 8080, port 3000. Yeah, I had this command saved, so that's nice. Let's change it from port 3000 to port 4000. We'll call it Kundan, and we're going to do this image name. So pop that here. Oh, yes. Good catch. All right, so we now have another instance going on. So I can do Docker PS, and now I can see that that this one is going to my host machine, port 5000. So if I go back here, I'll have so there's I picked the wrong port. There is a because of my Docker proxy actually tells it what ports it can really push through. I should not have picked 5000 there. I should have picked 8080 because that's what I had in the Docker proxy. So I'm going to do another instance. I'm going to do a third one, and we'll do 8080. And I can't pick the name Kundan again because that one's already been called Mad Shockley. Anyway, so it's going to my local host port 8080. So let's check this out now, 8080. And it's spinning up the assets for Ruby again.
Essentially just creating cache.
Yeah. Bingo. Yep, and then admin and just mumbled the password. So It's on the recording, I think. Anyway, so yeah, these are fully isolated instances. So if I say hi here, you will not see it on the other one. Why did it not pop up? That's a bit strange. Oh, I should have done this in a incognito window because they're sharing cookies. So I'm going to log out of this one. Maybe not. There we go. And then localhost 8080. Do, okay. Hi. So I mean, these are fully isolated environments. And if I use like a reverse proxy, I could make this all go on port 80 and then serve up, say, multiple customers having their own instances of this app. Just giving them different subdomains or different directories as the root. So I mean, thus you've created your own, hosting company really, really fast. You just automate spinning up containers, and then you can meet demand and whatnot. So
what's the limit in terms of how many can you some normal workload spin up on a machine with say 16 gig RAM or something?
Yeah, so this has 16 gig RAM, and you can do a lot. I don't know. I don't know the.
It's a memory limitation.
Right.
How much does your app use in a normal setting? So
yeah.
Half a gig you can spin up.
Yeah. So I mean, we could take a look at HTOP.
Right.
So I'm looking at HTOP here, and I'm not using up very much. Why don't we spin up some more? I mean, we could, right?
Yeah, because again, you don't have the overhead of the entire operating system.
That's right. So we'll do this again. So we'll make this HTOP here, and then here we'll just. I'm not gonna deal with port forwarding. We're just gonna know that it keeps spinning stuff up. So yeah, that's right. We cannot get to them. So. Oh. Oops. Here's HTOP. Still looks all right. Oops. My fingers are too fast.
Let's do Dr. PS.
Yeah, Dr. PS. All right, here.
30 of them.
38.
30, yeah.
Yeah. And we're still going. We're only at 5 gigs of RAM, so. This one. Okay, we're at 50.
So sorry, I'm back to my hard drive allocation.
Sure.
If you were real thing here
Yeah.
is that if you're a small shop and you want to act like you're Netflix or Facebook, and you want to do clusters, you can mix and match containers on the same machine in different Linux containers.
Mm-hmm.
So if you throw, like our image was just about a gig.
Yeah.
For the final build, and we have a couple of variations on that. If we were to build another, yours included a database.
That's right. Yeah, mine's doing. So actually, it's doing SQLite, but it could do Postgres.
Okay.
Yeah. So I don't know if SQLite counts. But
you could make if you were in this case, your application and database go together.
Yeah. That's right.
You could separate them.
That's right. So I could show you another example if you want. I've got another Docker container over here that I did recently. So I'm going to destroy everything you see here. We're still only at, 5 gig running, how many? Running 57 instances. So not bad. It'd be a different story, right?
That high, but.
Yeah, that's right. Big one does not exist.
In a way, when you think about do containers kind of take away the middleman, whatever the VM layer is, or the chef and these guys, puppet, do you really need them? Because a lot of people, they don't want to deal with OS.
Right.
On the app.
That's right.
So,
Yeah. Yeah, in fact, a lot of people are migrating to like Chef Solo. Instead of having a Chef server, they'll just use it for the provision automation.
Okay.
But all the dependencies are included in, say, a container, for example. So that way they're all there.
It also depends on what kind of orchestration.
Right.
So
Right.
if you have an HA proxy somewhere that's back-ended with a bunch of containers, you're still going to need something that says these are the IP addresses and ports of the containers you're talking to in the HA proxy.
Right.
So something like Chef or something that would be your orchestration part is still required. You just don't have a Chef anymore. It makes it much simpler. So I think they're complementary.
That's interesting.
It definitely reduces the need for something like Chef. And the guy who
My
really did
CPU. VirtualBox is taking up 213% of my CPU. That's interesting, and this is continuing to rise. I wonder if, it's because I probably did this Docker. I don't know. And then my destroy is taking a long time. You know what? I may just.
What's his name? Mitchell?
Mitchell Hashimoto.
Yeah. Right.
He's got a couple of other tools. Called Packer and.
Yeah, which those are really good too.
And Surf is
I
a
got it.
based protocol. He's got another one called Console.
Yeah, we probably should. You know, I may have to show you the. I may have to show you next time or another time the linking because we're running out of time this time. Thanks for joining us. I'm going to stop the broadcast, but then we'll do a little bit of survey on how we're doing with DevOps Live. All right. So thanks for joining us.